أنا
Wewe msichana unataka kusikia kelele yako? Good morning. Good morning. Hello, hello. So we wish to proceed from where we left last time. We want to see this concept of statistics, because we defined it as a science that deals with methods of collecting, organizing, analyzing, and presenting data for purposes of decision making. That we did see how to collect the data, and we saw how to organize data in terms of tables, and we concluded by saying that if the data is too large, then we prepare a grouped a frequency distribution, which gives us how the various values of a variable are distributed in a given set of data. This we call a frequency distribution table. So we did an example because we looked at how do we do that. We did say that we first determine the range, then we decide on the number of classes, then we get the class size, and then we proceed to look at tallying. So once we have determined, we tally. So after tallying, the table we generate is a frequency distribution table. We looked at examples, and what I'm giving is example 1. We looked at it in class. We looked at example 2, which I said you look at it, and this was about the age and death of people in a certain village that was recorded as given. So we were to group that using a class size of 5. So if you did that and you began with 30 to 34, the way I had said, then you will get the table that is being reflected on the screen. I left you with an exercise where the following was the height of students. And number 2, you are to group the frequency table using the starting class size of 5 and starting with the interval 142 to 146. Then we were given marks in a test, and we had to construct a distribution table with the intervals 0 to 9, then 10 to 19. So that is where we stopped. This morning, I'd like us to proceed and look at now the analysis. And we are going to look at this analysis at 2 levels. One is measures of central tendency, and then 2, measures of dispersion. When we talk of measure central tendency, these are measures that describe a given set of data using a single value. So there are basically 3 measures that can describe a given set of data using a single value. And the first is what we refer to as the mean, commonly used as the arithmetic mean. Because there are various types of means, we have the metric mean, we have harmonic mean. But to our level, what is common is this that we refer to as the arithmetic mean. This is the most commonly used average. And when we talk of an average, you are talking about the total sum of observations divided by the number. So this is for ungrouped data, or otherwise the discrete data that we talked about. So if you have observations, like consider the members of a family members, a household, as 2, 4, 6, 8, and 10, then the arithmetic mean is the sum of those members of the household, 2 plus 4 plus 6 plus 8 plus 10, divided by the total number, and this is giving us 5, and that gives us 30 divided by 5. But suppose the data was grouped, as in the case, then we must get the sum of all those, the sum of products of all the frequencies and the observations divided by the total sum of the frequencies, where the total sum of frequencies gives us the total number of observations. So we can look at that example that we are given. So in this example, we are given that the total number, which we can get by adding, which we can obtain from the table, that we look at this and then we say, how is it that we are going to compute? So we have the interval 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. So with the various frequencies as 9, 16, 19, 26, then 20, and finally 10. So we want to see how do we find the mean for this type of observation. So let us see from the table, how can we compute the mean for this type of distribution? So we are going to switch, and we'll be switching between this and the screen. Give it the focus. I hope you are able to see me. I hope you are able to see me. The picture looks still. Yes. Yeah, the table that we have is given on the board. That we are looking at the height, and the height is provided in centimeters. Then the frequencies in terms of the number of students is provided. So if we have such a table, this is already a group frequency table. It is grouped because it has intervals. Those that fall between 10 and 19, those that fall between 20 to 9, all group up 60 to 69. So the very first thing, let us confirm how many do we have. Add these frequencies to get how many students do we have in this case. So add this and get the total. Add this and get the total. Now, distributions. The mean we denote of a variable x, we denote it by x bar. This is given by sum of fx divided by sum of f. What is this? F is the frequencies that we have. These are the frequencies. X, this is the midpoint. X is the midpoint of these intervals, which consequently therefore means we must get the product fx. From this table, we have f. We don't have x. So what we need to do is that we first determine the midpoint, x. How do we define the midpoint? Recall in our first definition that we must determine the lower class boundary or limit. What is a boundary and what is a limit? I consider the interval 10 to 19. 10 to 19. Yeah. Please let us give us time. We check our connectivity. Let us connect so that you can see and follow us properly. Can we proceed? Be a little bit patient as we do the correct setting so that you can see what we are doing on the board. The board is just clean. Is it now okay? Can it be seen? Yes. So we are saying that we are looking at this distribution. That if we have collected data and we have generated this distribution, where it's giving us the height and the frequencies, we get the total frequencies. So if you got this total frequency, you have added. That we are looking at the mean. The mean is the average. So how do we find the mean of a variable x? This is our observation. So n observation, a characteristic of interest is x. So I'll say in our case is height. So how do we find the sum of fx divided by sum of f? Sum of f giving us the total number of frequencies. And sum of fx is the product of the frequencies by the x here is defined as the midpoint of the observations. So we need to determine the midpoints of these observations, these intervals, 10 to 19, 20 to 29. If you look at this, then you realize that for our case, the 9 are distributed between 10 and 19. The 16 are distributed between 20 and 29. So in this 9, we have included all those observations that range from 9.5 to 19.5. For the second, we have those observations that range from 19.5 to 29.5. Check what I'm writing in green. For 30 to 39, we are including those from 29.5 to 39.5. And this continues. So this is giving us a difference between what defined as the limits and the boundaries. Now, the first interval 10 to 19 provides us with the limit that this interval has to range between the limit 10 and 19. 10 is the lower limit, 19 is the upper limit. And this runs through. So those on the left are forming as the lower class limits. Those on the right are forming the upper class limits. But in a class of 10 to 19, we can include all those values from 9.5 to 19.5. In an interval of 20 to 29, we include those values from 19.5 to 9.5. The values 9.5, 19.5, 19.5 to 9.5. These are what are giving us what we refer to as the boundaries. The maximum extent within which we can include a value in that range. That is the boundary. Just the same as the way it is at home. You can always plow close to the boundary, but you now cannot get to the boundary. So the same concept is being applied here. We are including values
up to and what's in the boundary. And the boundary is the last point of sharing. Where the last one ends, that's where the next starts. Where this ends, that's where the next starts. That is the boundary. In statistics generally, it is common practice that we must always ensure that the observations that we have do not coincide with the boundaries. Because if I had a height of 19.5, it will be difficult for us to decide to put in the first or second interval because that is the boundary. It's no man's land. Nobody can claim for that. So we always aspire to ensure that no observation will fall on the boundary. So with this in mind, therefore, we can proceed to find the midpoint x. The midpoint x is just the average of those boundaries. That I have 10 to 19, 20 to 29. Now, if I use the number line, that I have this as my number line, this is 10, this is 19, this is 20, this is 29. That the first interval extends up to 19, but we can include up to 19.5. This is what we are referring to as the boundary. So from this, it will start from, say, 30, and it goes on up to 39.5. So where is the boundary for this? The boundary for this is in between here, 29.5. So how do we find the midpoint? This is our midpoint. This is our midpoint. So these midpoints are what defines x. And we can find them by simply averaging the boundaries. That is what we are saying. That we are extending from 19.5 to from 9.5. So if I average 9.5 plus 19.5, this would give me, this is 2029. Divide by 2, that gives you 14.5. That is what is giving us the average. And the same can be obtained by getting 10 plus 19 divided by 2. So 10 plus 19 divided by 2, that gives us 14.5. 9.5 plus 19.5, that still gives us 29. Divided by 2, that gives us 14.5. So the midpoint for the first interval is 14.5. We do the same for the second interval. 20 plus 29 divided by 2, that gives you 24.5. The same trend continues. And if you check, you find that the difference between the first and the second is 10. If you find out the class size here is 10, we didn't see how to find the class size. So this is a regular form. So we can complete the rest. This 34.5, 44.5, 54.5, then 64.5. So with this, we have generated our x. So what we need, because we need sum of fx, so we need the product fx. Fx giving us the product f by x. So 9 times 14.5. See what it gives you. 16 times 24.5. See what it gives you. Complete all this and get the total here. Sum of fx is equals to. Provide the total here, sum of f is equals to. Do that in a minute, then we see what we get. Please take a minute to find fx and the total there. You have a minute, please do. Let me check what it is there. You can provide your answers on the chat box. Somebody's already giving sum of fx, 5270, 52.7. Continue streaming in your answers. Somebody's getting 40, 70, please check. Please check. Thank you, Leonard, for getting me loud and clear. Please proceed quickly. Let's get the answers. Are we through? So what I'm seeing is that when you add all this, you get 40. When you add all this, most of you are getting 40, 70. And therefore, our mean for this distribution will be 40, 70 divided by 40, and that gives you an approximate value of 40.70. 40.70. So the mean of this height is 40.70. How do we interpret that? We are interpreting as we go by. The average height of this student is 40.75. That is what we are talking about. F is 100. F is 100, sorry. I've written 40 instead of 100. Please, F is 100. If you add this, you get 100. If you add this, you get 40, 70. So the average here is 100. Then that gives you 40.70. Thank you for noticing that. And that's about the mean. The next item we look at is what we call the mode. The mode is the most occurring value in a data set. So if it is discrete, then we are able to determine what the highest occurring value is. But if it is not, then we have to provide an estimate. Look at the following. Where do I go to? Huh? I share screen. Now look at this. That we want to look at now the mode, and we are saying that this is the most occurring. What is it that is most occurring is what has the highest frequency. So if you have a set of data like 10, 30, 40, 20, 50, 60, and 20, then we arrange this in a data array form. So as a data array form, then we are arranging in either descending or ascending order of magnitude. So what is at the highest, the one that occurs most? As for this case, the value 20 is occurring twice. So that is the most common observation. Look at example 2 on the accidents caused by different vehicles. Lorries 10, cars 40, buses 22, matatu 16, others 12. So you look at which one is causing most deaths. And in this case, it is the buses because it has a death rate of 22 people. This is for ungrouped data or discrete data. But suppose it is grouped. So if it is grouped, then we want to look at it in a different way. That we want now to estimate so that we give the correct value. We estimate the correct value. And as we do this, we wish to see what is it that we are to look for. If that is the value that we have to go by, we are looking at the mode. Allow me to write here. This is L plus, we can say F1 plus F2 divided by F1, and this will multiply by I. What are these? This is what are saying change 1, change 2, change 1. That what is L? The lower class boundary. So if we look at this, then we must identify what we call the model class. The model class is that class that has the highest frequency. So if we look at a given set of data, we must look at the frequencies and see which one has the highest. Then from that model class, we determine L, which is the lower class boundary. Remember, we have explained these are the boundaries, the one in green. So the lower one is the one on the left. Now, when you talk of change 1, F1, we are looking at the difference in terms of the frequencies of that model class and the one that's coming before. The second one, the difference between the model class frequency and that which comes after. I, we define this at the beginning. This is our class size. So from our example here, we want to look through which one is the highest frequency. I have 9, 16, 19, 26. So I have this with highest frequency. So for my case, my model class here will be that of 40 to 49. So if my highest class is 40 to 49, what is my lowest class boundary? My lowest class boundary is, if I continue this, this will be 39.5, then 49.5. 49.5, 59.5. 59.5, 69.5. So my lowest class boundary here will be 39.5. My F1, this is my model frequency. So 26 minus 19. 26 minus 19. That gives you 7. F2. The difference between the frequency of the model class and that comes after. 26 minus 20. 26 minus 20, and that gives you 6. Then what is I? I is the class size. You look through, we saw that our class size I is 10. We are getting everything from the table. Then we can now substitute mod, which we can refer to as M subscript O, as substitute in the formula and get the answer. Let us substitute in the formula and get the answer. And we will summarize everything. That one is F1 over, no, that has corrected this, F1 over F. Please correct this. This F1 all over F1 plus F2. It's in the denominator. F1 all over F1 plus F2. Correct this kindly. Correct that formula. So our mod will be L plus F1 all over change 1 plus change 2, multiply this by I, and this will give you L is 39.5 plus F1 is 7 all over 7 plus 6 multiplied by the class size 10. You work out that, you get 39.5 plus that value, and that will give you the last item. Please do that. Wanapata majibu? Okay. Let us proceed and now look at the third measure of central tendency. This is what we refer to as the median. The median is the value that takes the central position in a data set. So if you arrange the data in ascending or descending order, that which takes the central position is defined as the nth over 2 item. Consequently, therefore, if it is discrete, then you just arrange and get the nth over 2. If there are 2 middle values, then you average those 2 middle values to get the median. But if what you are doing is grouped like this one, then we need to know how do we proceed to compute that. That for the median, we have to look at it and see how we interpret the given intervals so as they give us an average or estimate value of the median. You have a guest? Okay. So let's see from this example, how do we proceed? That we can estimate in a group set of data, such that now for us to determine the median, which we can denote as MD, this will be equal to L plus N over 2 minus the CF divided by F, this multiplied by I. L plus N over 2 minus CF over F times I. What is L? L is defined as a lower class boundary, as we have seen earlier. N over 2, this is what is giving us the central value, the central position. because median is a measure of position. CF, the cumulative frequency, CF stands for cumulative frequency up to the class preceding the median class. F is the frequency of the median class. I is the class size of that median class. That's how we interpret this. N over 2 gives us the central position. CF is cumulative frequency up to the class preceding. F is the frequency of the median class. And I is the class size. Coming back to example, so we have all this except now the CF. So we want to complete the CF, cumulative frequency. Now we are asking ourselves basic questions that how many students have a height of up to 10? That gives us 0. How many students have a height up to 19? So up to 19, we have 9. So our cumulative frequency in this case is 9. How many students have a height of up to 29? So for up to 29, it's 9 plus 16. That gives us 25. How many students have a class size of a height of up to 39? So up to 39, we have 19 plus 16 plus 19. That gives us 4. That's 3, 4. Please check. So what we are doing here, we are accumulating the total. We are accumulating the total. Because up to 49, we shall add 26 to this, and that gives you 70. Up to 59, we add there 20, and that gives you 90. And up to 69, we have a total of 100. We have a total of 100. So if we are looking for the median class, so the median class is determined by n over 2. Where is our n over 2? Our n is 100 divided by 2. That gives us 50. So where is this item number 50? In this. So up to here we have 45, up to here we have 70. Meaning that number 50 lies among the 70, and this 70 corresponds to the interval 40 to 49. So our median class here, median class is 40 to 49. So out of this 40 to 49, that's where our half center value lies. What is our L? Our L is the lower class boundary. What's the lower class boundary of the interval 40 to 49? It is 39.5. What is our CF? CF here is the cumulative frequency up to the class preceding. Something preceding is what comes before. So we are here. What comes before is 44. So our CF is 44. F is the frequency of the median class. We are at 40 to 49 with a frequency of 26. So our F is 26. Our F is 26. Then our I, our class size, is 10. So we have all those information, and therefore our median is L plus N over 2 minus CF all over F times I. And remember, we had N over 2 already. N over 2 was giving us 100 over 2, and that gave us 50. So when you substitute this, you get L is 39.5, plus N over 2 is 50, minus CF 44, all over F 26. This multiplied by I, which is 10. You can evaluate that. Get a minute, evaluate that. Let's see what you get. 41.81. Naona mtu ameandika 43, 41.81. Please check so that we have the same answer. Somebody's writing medium, not median. Juliet Wafula. Juliet Wafula is median, not medium. Check. People are getting 41.81, you are getting 43. Please check. Your screen battery on. So most of you are getting 41.81 or thereabout. So that is the median. So we saw that the mode was 40.70. The median is 41. The mean was 40. The median was about, you got to 44. So we have those three. So look at the following example and let us find the mean, mode, and median of this data. We have 1 to 10, 11 to 20, 21 to 30, 31 to 40, then 41 to 50. This is our observation. Say whatever it is, observation. Then we have these are the frequencies: 8, 14, 12, 9, and 7. Estimate the mean, the mode, and the median. Find those values. This is our example 2. The mean, mode, and median of this set of data. Find the mean, mode, and median of that set of data. The focus kwa hiyo copy. Wakimaliza tunaenda ya mwisho. Dispersion variance. Vincent Nyachai, you are getting 443. No. But 1.81 is okay. Felix Weta and Michael Ndenga, you are giving the correct information. Keep it up to help your friends. You protect your hand is up. Once you are done with the example 2, give us the mean, mode, and median. The mean, mode, and median. Mode 24.1, median 22.63, mode 14.5. Please check. Please check, please check. Results are streaming in. Please check. Please check. We conclude. We want to finish off this. Now we want to conclude about a comparison of these three. You have the answers. Please, you can verify. When the mean equals to the mode and equals to the median, then that type of distribution is called a normal distribution. It's called a normal distribution. When the mean, mode, and median are equal, most often we ask, give a comment. A comment means you compare these three. Are they of the same value or about the same? If they are of the same or about the same, then we say that that is a normal distribution. When the mean is not equal to the mode and is not equal to the median, then we call that a skewed distribution. When these three measures are not the same, then it's a skewed distribution. So skewed distribution can either be positively skewed or negatively skewed. When we say it's positively skewed, the mode is the highest. When we say that it's negatively skewed, the mode is the least. So we use the mode in our case to determine whether it's positively skewed or negatively skewed. If the mode is the highest, it's positive. If the mode is lowest, it's negative. That is the comment, and that is the interpretation of what we are saying. Then in terms of node number 2, we have said that the median is a measure of position. The median is a measure of position because it's giving us the central value. That value which takes the middle position. But there are also other values that can be used to describe position. Take, for example, the quartiles. This is represented by Q. The mode, you saw we were saying n over 2. It is dividing data into 2 equal parts. From the word quarter, we are dividing the data into quarters, and quarter means 4. Therefore, we can estimate the ith quartile or the kth. Let me use k so that we don't confuse. This is the same measure of position and takes that of the median. This is L over Kn over 4 minus Cf all over F times I. For K will take on the values 1, 2, 3, and 4. That on our number line, we are dividing this set of data into 4 equal parts. 1, 2, 3, 4. So in our computation, we shall have quartile 1, quartile 2, quartile 3. The fourth quartile means it's taking the whole of it. We have 4 parts, but 3 divisions. So we are only changing the Kn. If I'm looking at the first quarter, K is 1. K will be 1. If I'm looking at the second quarter, my K will be 2. If I'm looking at the third quarter, my K is 3. So we only substituting this, and the rest now follows. So that I look at my Kn over 4, where does it lie in the category of the CF? Then I pick and interpret L. We can also look at it in terms of deciles. A deci means 10. So the kth decile is therefore L plus Kn over 10, because decile means 10 minus CF all over F, this multiplied by I. 4, K will take on values 1, 2, 3, and so on up to 9. This will take up to 3 because the other one is not there. So they will go up to 9 for the ith, kth decile. The computation still follows that of the median. Then we can talk of percentiles. This divides a given set of data from percent. Percent means 100. So I can get the kth percentile as L plus Kn over 100 minus CF all over F. This multiplied by I, 4. K takes on 1, 2, 3, up to 99. These 3 are measures of position. These 3 measure position just like the median. Now you find out that the following are always true. You can work out as many as you can. That the median of any set of data, this is the same as the second quartile, which is the same as the 50th percentile, and which is the same as the 5th decile. This is always true. You can vary and do all that that you want. You can also compare this. If I'm looking at the first quartile, this should be the same as, it's like 25%, P25, which will be the same as D 2.5. This is also true. It gives us the same results. So work out using the 2 examples to confirm that truly Q2 equals to P50 equals to D5, and Q1 equals to P25, which is equals to D 2.5. We can ask any question about measures of central tendency. Ask any question because we want to look at measures of dispersion. We can allow them to breathe a bit. You said I share.
So this is what we are saying, ladies and gentlemen. I've given you that example, you work on it. Estimate the mean, the mode, and the median. This was example 1 that we did. That's example 1 that we did. We have talked about related measures of position, the quartiles, deciles, and percentiles. And now you can screenshot that for your purposes of your exercise. The following scores were for 100 students in a KCSE Kiswahili 100 exam. Make a group frequency distribution table starting with 25 to 29. Determine the mid, mode, and median mark, and give a comment. You can also find many of those percentiles, quartiles, and what have you. Now let us look at measures of variation. When we talk about variation, we are talking about those measures that describe how a given set of observations differs from a central value, which is usually the mean. Of the three measures of central tendency, the mean is the most important one. Why? Because it's highly responsive. Because if you change a value, the mean will change. The mode might remain because that's a measure of position, and the one of the highest frequency will always remain, and that's the mode. So as we look at this, we wish to see how or what should a good measure of variation possess. It must be simple to understand. It must be rigidly defined. Should be easy to compute, and it should have each and every observation of the distribution based on it. And now, if those extreme observations are duly affected, that is what describes the best. So we want to look at how do we study variations. Variations come in various levels. The simplest is the range. The range, as we saw earlier, is the difference between the largest and the smallest observation. Then we have looked at the quartiles. There's one we refer to as the semi or the interquartile range. This is the difference between the third and the first quarter. That gives you the interquartile range. But the quartile deviation is the average of the interquartile range. Third quarter minus first quarter divided by 2. This is also described as semi-interquartile range in some books. But now of importance is how do we determine variability is by way of the standard deviation. This is none other than the positive square root of the mean deviation. That's the simplest way to describe it, because we get the sum of the differences, the square deviations. But as we talk about those deviations, we are looking at how do they differ from a central value the way you have described. How do those observations differ? That's what gives us the difference. That's what gives us the deviation. So how do we interpret the standard deviation? The smaller the value, the more homogeneous the observations are. Homogeneity in this case is describing the similarity and how the observations are identical to each other. So we look at this and we say that, yes, they are identical if the value of the standard deviation is small. Yes, they are not identical if the value of the standard deviation is big. So with this in mind, therefore, we can go further and advance and determine what we call coefficient of variation. Coefficient of variation is just the percentage proportion of the variance or the standard deviation that can be explained. So how do we find this? It is the standard deviation divided by the mean times 100. Because the mean is the most important central measure of the items. So we can look at that and then see how do we proceed to compute this. Now look at this example that we find the deviation from the weekly wages of 10 workers in a factory. Let us look at that. The one I've screenshot. So find the mean for the weekly wages. Find the mean for the weekly wages. Find the mean for those weekly wages.
Hukuma niandika hapo mwisho maformulas. Onyesha huko. So we are talking of the standard deviation. This being the positive square root of the sum of the deviation squared all over n. That is for ungrouped data. Or if it is grouped, the positive square root of sum of fd squared all over sum of f, where d is x minus the mean. So in our case, therefore, we have the workers, then we have the wages. So we need to get first the mean. We know how to get the mean. Then once we have the mean, we get those deviations. So in our table where we have the wages, so we shall have the deviations. Then get deviations. So this is the total that we want down there. If the data occurs with frequencies, then we shall get the deviations after finding the mean. Then get deviations squared. Then get fd squared. This is what we are up to for grouped frequencies. This for grouped frequencies, this for ungrouped frequencies. So in our example 1, this is discrete, and therefore we want to use the first formula. In our example 2, we are going to see for this grouped. So with this example that we have given, can we find the deviations, which is d minus x, then deviation squared, we square these deviations, then get the total and proceed to substitute. In our example 2, we are going to do this, then we get the fd squared. So let us work out on that example 1. Then we proceed to see what happens later and the interpretation as we wish to move the last section of this topic on standard deviation. How did you come in? You came in like a thief, no?
Please try and wind up. Share your answers.
Are we through? Hiyo 14 ya hii ilikuwa ya kitambo. So look at what you have gotten. If that's what you have gotten, go to example 2. The age and death of patients in a certain hospital was recorded as follows. Do example 2. The one that is projected. Work out example 2. Now, please check the following so that we wind up. Please check the following so that we wind up. The solution to that, the mean is 51.29. The variance is 73.30. The standard deviation is 8.56. That is the working for that solution. Kindly check. You can at your own free time find the mid and median and then compare. You can also look at this. This was to be exercise example 3. The table in 10 meters of 50 children attending a clinic was recorded as given. If you work out, please screenshot. You should be able to get the mean as 46.10, the variance as 30.69, standard deviation as 5.54. Then proceed to get the coefficient of variation. The coefficient of variation in this case is the standard deviation divided by the mean times 100. And as I said, that gives us the percentage proportion of the explained variations within and among the distribution. Please copy that. Then I have exercises for practice. The first one is given, and these are standard type questions for exams. The data is on mass of students, first year class. Estimate the mean, mode, and median weight and comment. So the comment we expect here is that you are telling us, is it normally distributed? Is it skewed? Evaluate Q3 and Q1 and hence the interquartile deviation. Calculate the variance and standard deviation of the data. Then what conclusions should you make from the data? The conclusions are basically, how do you interpret now the value of the standard deviation? Is it homogeneous group or is it heterogeneous? Are they identical or are they not identical? That's what we are looking for in that part D. So that is an exercise you can do in groups, discuss. If you have issues, kindly check with me. And finally, example 2. This is a bit tricky and you need to know it very well. Understand the table that has been presented. Understand it properly and clearly. That we have 2 sets of radios, Sony and Panasonic. So you estimate the mean, median, and model life of each of the radios. So you work out for Sony, then you work out for Panasonic. So estimate the standard deviation for each. You work out for Sony and you work out for Panasonic. Then the basic question is in 3. Which of the models would you prefer? Give reasons. So for you to determine which is the best, so you need to compute the coefficient of variation, which gives us the explained variation. So that has little, the smaller the variation, that is the best. I repeat, for us to choose which is the best model, we compute the coefficient of variation. So that which has a smaller coefficient of variation, that's what gives us the best. And finally now, how do we represent the data? We have been interpreting as we go by. Data representation is by way of graphs. And graphs normally gives us a relationship between two variables by way of a curve or a line. How do we construct graphs? They must have a clear and comprehensive title. Independent variable is always on the x-axis, and the scale should always be uniform on the x and y. That graph should not be overcrowded, and lines must be distinct. The source of data must always be indicated, preferably at the bottom. So if we look at this, then we can look at a few cases of graphs, and you can read more. So there is that bar graph that uses distinct bars to show data, line graph that uses lines, histograms that uses the class boundaries, the pie charts or circle graphs, which gives us the proportion in form of degrees, and then we have the Lorentz curve. So a frequency distribution can be presented graphically in any of the following ways. We can give it as a histogram, we can give it as a frequency polygon, we can give it as a frequency curve, and we can also give it as a cumulative frequency curve where we are using cumulative frequencies on the y-axis. So you read about this and how to represent the data on that front. I wish to embark on questions, maybe on the chat box. Okay. So as we wind up today, I want to reiterate and make it clear as follows. On Thursday, we shall have our cut 2. On Thursday, we shall have our cut 2. Cut 2 will cover everything up to what we have covered today, excluding what we covered in cut 1. So you know where the coverage will be. Announcement number 2 is that I'll not entertain any form of excuse for missing the cut. You have today, tomorrow, and Wednesday to sort out anything to do with the connectivity and the portal. I'm teaching from the Odell office. Come and sort out any issues if you have. Thursday one, I'll not entertain any form of nonsense. Number 3 is that we shall meet on Monday, same time like today, to look at the last topic, matrix algebra, which I hope to conclude on during the Thursday class. So I plan to conclude these lectures for this course next week on Thursday. That is the program, that's the schedule on how we are going to conclude this course. At this juncture, therefore, I wish to wish you a nice weekend and request that the remaining topic on matrix algebra, we shall deal with it next week and hopefully complete by Thursday. Unless there is a question, I'm ready to respond. So I thank you very much for giving me the makeup. I thank you very much for giving me the audience. So let us adjourn unless there's a question. Please feel free and mute them so that they can ask questions. If you have a question, please unmute and talk as we conclude the lesson. I've given you enough exercises for practice. I'm available for consultations this week. I'm available for consultation this week. So please, let us see. Ensure that you vote wisely and you don't fight. Upper quartile, deviation, or percentile, yes, they are like measures of position. If you have an issue, Otimo, you see me. Mercy Nekesa, your hand is up.
Today is Monday lecture.
Huh? What I'm seeing is Nekesa.
Once weekend too.
So if you have no question, let us adjourn until next week for the lecture on Thursday. Log in on time. The cut will be what time? 8. The cut will be done from 8:30 on Thursday. Hope I'm clear. The cut will be done from 8:30 on Thursday. The rules are clear. You remain idle for 1 hour to switch you off completely. Hakuna ya kusema nilikuwa natumia simu ya mwingine. Learn for the cut yourself. I hope you now understand. Thank you so much. May God bless you. The lesson stands adjourned.
Hapo kustima imepotea ba.
Mawe estimate vile.
Ubuguzi nyingi.
Hakuna stima kila mahali.
Wasenywe. Hole kuchetu utiwasi.
Tisi na sirio.
Wabukusu tokeni hapa tuwapigi.
Ewe sila la hand.